Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to solve an application involving the natural logarithm. The percentage of U.S. full-time college students who receive some financial aid in a particular year can be described by the function f of x equals 58.8 plus 6.7 times the natural log of x, where x is the number of years after 1991. Use this function to predict the percentage of all students that will receive financial aid in 2025. So this part of the problem is a simple evaluation of the function. The second part of the problem you can see at the bottom of the screen, we're actually going to have to solve a logarithmic equation. So let's begin with part A. 2025, I need to know what year that is. And so x, remember, is the year minus 1991. So in this problem, 2025 minus 1991 equals, how many years is that? Well, you can do it on your calculator, but I do know from 1991, it's 9 years to get to 2000, and another 25 to get to 2025. 9 and 25 is 34 years. So I'm trying to predict the percentage. That means I'm looking for the function value. I need to find f of 34. And the function's equation or formula at the top is 58.8 plus 6.7 times the natural log of x, which here is 34. So I've got everything I need on the right-hand side. I just need to go to the calculator. One thing to be careful of, again, that 58.8 and the 6.7, you can't add those together. The 6.7 is tied to the natural logarithm. 58.8 plus 6.7 times natural logarithm, ln, back to main of 34. Let me just make sure that I've done that correctly, that I didn't forget any of those numbers. Yeah, 58.8 plus 6.7 ln 34. 58.8 plus 6.7 times ln 34. And here we've got 82.4266. It didn't tell us where to round, so I'm going to round to one place here, and that is 82.4%. Right. So in 2025, we expect it to be 82.4% according to this function. Now in part B, we want to try to figure out when is it going to be 85%. This 85%, this is the percentage that get financial aid. And what we're trying to figure out is what is the year. So that means we need to figure out x first. And so this 85, that is the function value, and we need to solve for x. So let me copy down the function again. F of x equals 58.8 plus 6.7 times the natural log of x. Let me make sure that's correct. That's correct. And we want to figure out when does that equal 85%. So 58.8 plus 6.7 times the natural log of x equals 85. How do we solve that? We need to have it in the form natural log of x equals some number. So we need to start peeling these numbers off. First, we can subtract 58.8 from both sides. And that leaves us with 6.7 natural log of x equals 85 minus 58.8. That is 26.2. Divide both sides by 6.7. And I'd recommend trying to divide this on your calculator. You'll notice that it fills your calculator window up. Let me show you what I mean. 26.2 divided by 6.7. So we get that decimal. So I can't replace that with a decimal. I want to keep as much accuracy as possible. So I'm going to leave that fraction the way it is. So natural log of x equals 26.2 over 6.7. I need to change this to exponential form. The base of this logarithm is e. So e to that power, 26.2 divided by 6.7, equals the argument of the logarithm, which is x. And so I just need to figure out what is e to that power. I can do that on my calculator. Function e to the x, parentheses, because I need the 26.2 divided by 6.7 all in the parentheses. 26.2 divided by 6.7. And there I get 49.9. That's approximately 50 years. I'm going to come back and I'm going to show you now. So the 49.9 is right. But if I didn't use the parentheses, I might make a mistake and not even see it happen. Function e to the x, back to main, and I'm not going to use the parentheses. I type in 26.2, and when I push divided by, meaning to divide 26.2 by 6.7, oh, it worked. Sometimes that doesn't work. Sorry about that. Oops. Yeah, so I got the same thing there. There are times, depending on what you're typing, where that's going to move that into the denominator, and then that's trouble. Okay, 49.9, or approximately 50 years. So x is approximately 50, but I want to know what year that was. And again, remember that x was the number of years after 1991. So the year is 1991 plus 50 years, or 2041. Come back in about 20 years and let's see how that prediction worked. All right, that's it for this section. I will see you in the next and last section for this chapter.